Okay, I think. Oh, that's good. So, welcome to the symposium we call Improving the Outdoor Comfort in the City, Impact on Public Health and Energy. We are organizing this symposium today around our sustainability class, and we have people from FAR as lecturers today. So I'm welcoming Mr. Chongqing from the company Chongqing from China. By education, he's an architect, and he's today the deputy director of a certain region in China, responsible for green buildings. So maybe as a background on Chongqing is the biggest Chinese developer on the Chinese market, as I heard, building 150,000 apartments every year. So in a certain way, and their intention, and I thought that's quite interesting for our discussion, we have even here in school and in the class, that their intention is to think not only on indoor comfort and green buildings, but as well on outdoor comfort in connection to their buildings. And Mr. Chongqing will mainly talk about this, because expecting that has as well not only an impact on the happiness, which I think is quite interesting, on the happiness of their kind of tenants, but as well an impact on energy in respect of that people may stay more outside and spend less in fully air-conditioned spaces. So I think that's what we'll hear. And then we have as a second talk Mrs. Yi Jiang from the Built Environment Group in Chongqing, China. She's a mechanical engineer by education, and she will talk about quantitative and qualitative studies on outdoor open space quality in different occupants activities. As a third speaker, we will have our good friend Peter Rose. A lot of students know him as a teacher here at the GSD, Peter Rose and Partners Architectural Office here in Cambridge. And Peter will talk about master planning for the people, and using two examples. One is a master plan he's doing for Toronto, and then the second one is a master plan we even did together in a competition in Helsinki. We unfortunately lost because we were too tough. We changed the master plan in a competition. And then fourth, I will give you, and Peter is an architect, as everybody knows. Fourth, I will give a talk on perceived temperature and outdoor comfort for a certain project in Qatar. The heart of Doha is a new redevelopment in the center of Doha, where we were kind of hired to improve the outdoor quality of the outdoor space. And then finally, I welcome Yves Blau, who is a professor at the Department of Urban Planning and Design, and Yves will take the lead in the following panel discussion, where in a certain way, because this outdoor comfort, and that's why I invited Yves, and she was nice to accept this invitation, because in the first moment you would say, what has this to do with urban design? And I think it has a lot to do with urban design, because if we talk about the quality of outdoor spaces, this will have as well a big impact on our urban life. So, and therefore, urban design planning, luckily we get Yves to do the moderation of the talks at the end. I'm guessing we do like 3 talks, then we do a 15-break coffee break or water refreshing break, and then we go on with the 4th talk and the panel discussion. So, and I think we will typically try to keep the talks in the range of 30 minutes, and I will be the guide. Hopefully I will do it on my own as well. And then, so that we have enough time at the end for the panel discussion. And I think if you have questions on the different talks, take notes and ask them in a certain way. We will start the panel discussion, but then as well have the opportunity for people to ask questions to the lecturers. So, therefore, I'm stopping here and give the floor to Mr. Chongqing, and it's this one. Okay. So.
Thank you, Mattis. Okay, firstly, thank you for Mattis for organizing this place for me to introduce what we have done in China. And today I want to talk, the topic is about back to origin. As sustainable building is only for achieve the very good result like the carbon zero or something. The key point for the sustainable building is for the occupants. It's the people living inside and also living outside. So today's topic is how we will think about our sustainable building and how we decide the buildings by occupants' behavior research. So the outline will include five parts. And first, I will have a brief introduction for what we are facing in China, because everyone knows Chinese are experiencing the fastest urbanism around the world, and surely this will bring many problems with the urbanism. And this will arise questions we think on the road to sustainable building, and we will introduce what we develop according to our rethink. And then in the further research, and I will introduce Mrs. Yi to introduce what we have do this research on the outdoor comfort. And finally is our view for sustainable future. First of all, let's see some interesting photos. And this is 20 years ago in Pudong in Shanghai. And see there's nothing there, only the reputable garden or trees. And after 20 years, you will see Shanghai change a lot, become a new city, especially for Pudong. So you can see 20 years change a lot. 20 years is a new city in China. And same, not only the coastal city, but like the southwest city, Chongqing. Chongqing is here, and inside the Sichuan province. And this is famous CBD commercial center in Chongqing, and you can see that also a big difference in 20 years. And these two rivers, this Yangtze River, this Jialing River, so the colors are different. And this Shenzhen. Shenzhen is quite close to Hong Kong, and some people maybe have been there. And here you can also feel the train sharply, many high tower rising 20 years. In this CBD, you can see the CBD during the after the work. You can see just like the car parking on this high bridge, and also before 20 years, it's just many hutong and many local buildings around. And you see China is growing very fast. And there's some data. In the past 20 years, we are experiencing the fastest urbanism around the world, and Chinese urbanism population increased the equivalent to fourth of U.S. citizens. Then you see the fourth the U.S. citizens move into the U.S. Chinese cities. They will be great because we should build a house for such people, such great among people. And in the coming 9 years, it also 1/3, the equivalent to 1/3 of U.S. citizens will move into Chinese city. And this is the greatest number. And sure, with this fastest urbanism, the energy consumption will increase so fast. And by 3 cases from some doctoral papers, we can see in the 10 years, the building energy consumption is supposed to increase close to twice, similar to by the difference assumption by the urbanism and energy saving rates. So we can feel it in the coming 10 years, we will consume twice as that of 2009 energy consumption in the city. And inside this building energy consumption, the urban residentials will consume more than 50% of the whole. So this means the residential building will consume the most energy inside this, or the whole energy consumption of the society. So we will consider about the residential building very much. And as that, what we are facing is, it is clear that we are experiencing the greatest human immigration of human history. More and more people move into Chinese city in China. And sure, this will bring the biggest residential market around the world. And then with this the fastest resource consumption speeds. And then also can bring such level of Chinese Wanqi. And here we will have a brief introduction for who we are. And then Wanqi is personally the largest real estate developer in the world. And we have more than 30 cities around the world, and also across many climate zones, from north to west to south. And I come from Chengdu, is here. The Chengdu region is including 7 cities from this northwest and to the south. And you can see all this city will bring many customers and many owners. In last year, we sold around 20 billion US dollar and provide more than 115,000 units for 368,000 owners. So we have many clients, and this speed will just continue. So in the coming 10 years, we will still experience such high speed, depending on this fast development. And so as the biggest and also largest real estate developer, we should take relevant social responsibility. So we are also the biggest green residential building supplier in China. And in last year, we will provide more than 50% of the highest level of green building. In China, we have green 3-star buildings similar to the LEED Platinum in US. And also we try to do something latest advanced building. For example, like our Wanqi Center, developed and designed by Stephen Hall, and we achieved the first LEED Platinum award from the real estate development in China. And even in last year, in the Shanghai Expo, we established a very interesting building for Wanqi Pavilion and used a straw ball. And after the Expo, we just demolished it and just become nothing. And I think some students of you of GST have been to R&D Center in Dongguan. This is very big R&D Center. We will mix more research for the building technology and some the prefabricated concrete technology also. I think some GST student has been there. So under this greatest, biggest, and fastest situations, they will give us a rethinking. Also, we can do some green buildings according to the national standard, like 3-star or LEED. But this is only just following the standard. But these green buildings, I can say, haven't raised a very good response from the market. Maybe we decide or develop this building for the government. So, is it the only road to sustainable future? We think about that. So there's 2 cases will help us to rethink the future to the sustainable. So this is a good case. It's also a good market case because it has good sales, and his sale price is around 20% higher than us. And this building is quite interesting and quite comfort with many high techs in China. For example, like heat pump, and also have good air tightness and shading around the facade. And also use the latest European technology, ceilings, gradients, and use also the fresh air all around the house. But in fact, the energy consumption number is not that good. The average level is 3 to 4 times than the local level. So what we will think if we use many high technology to achieve very higher comfort level. But this is energy saving? from the view, from the energy view, you think this is not that so. Maybe this is designed as a very green building, but the energy bill is not that energy safe. So we are just thinking whether we should use very many high techs to arm our buildings.
The 44, sorry for asking,
Okay.
the 44 kilowatt hours you're listing as total.
Yeah, so it's
This
a whole year.
electricity that's electricity consumption per square meter a year.
Yeah.
For heating and cooling, only, or including lighting and ventilation?
No, not doesn't including lighting.
Just cooling.
Just a cooling system.
Just cooling. Okay.
System. So it's more higher than this average level inside this city. Normally for the normal building, we consume 15 kilowatts per square meter a year. And also there's interesting comparisons of air conditioning in Beijing, and we can see different AC system, air conditioning system, and their relevant net energy consumption level. And here we see, sorry, this is some slide from some conference. And this slide you can see there's 5 case, and 3 case belongs to split AC air conditioning, and D and E is for individual central DC and fully central AC as well. And we can see the energy consumption rate is the interesting result is the split AC is most energy saving tech equipment in this market. And you can see this split AC is really traditional and you see it everywhere. And here there's many latest high technology, but the energy bill is not good. So we're also thinking what is the sustainable future? Should we use many high tech to achieve, to make our building with many high technology, or we should think another way? So we are thinking about the difference of energy consumption comes from usage mode, because this part-time mode or full-time mode. Because this building we used, they call it constant warm and constant humid by one system, and maybe just by one measurement to control the machine. So maybe the different rooms, the different behavior of different space will influence the system. And also this different comes through the environmental index. For example, like we open a window or just all the people stay in this enclosed space, and we shut down all the windows and only use these 4 radius to keep our indoor temperature and humidity. Maybe sometimes in some past season, just open the window and also can achieve the similar comfort level. So there's the constant temperature and humidity virus outdoors climate change. And also depend on the control system, self-control or not, or maybe controlled by the occupants or by the systems. So just we have to think, does technology solve everything? But from the result, we think the technique doesn't solve everything.
So,
then we're just thinking about the sustainable.
and I was just certainly thinking on, if you go back 2 slides, what is I think remarkable, 1 slide more. It's remarkable that in this slide it shows the individual split units, which are definitely by efficiency less efficient than the central unit, are using per square meter less electricity than the central unit, which is definitely double efficient. But in this case, it's just used. I think the decentralized split units are only used when it's really hot, and maybe they are so noisy that you really only use them when it's really unbearable, while the central, you think it's a comfort, and you expect to have the comfort 24 hours. That's why it's kind of 6 times more.
Sure.
So,
depends on the usage custom, because maybe just for 24-hour comfort, or maybe you just need 7 hours.
Yeah,
2 hours comfort. Yeah. And maybe some rooms with people, and without people, they still work. For some still, when you switch on, all the house is comfort. But sometimes you don't need that.
Okay.
Yes.
Sorry.
Is any of that related to who pays the bill?
Yeah.
Are they individual bill payers?
Yeah.
Yeah, individual.
As opposed to a combined bill?
No, you are metering in the central system. You are as well metering the kilowatt hours, or you do it more. You split it by square meters.
Sorry.
Depends on, I think it's on the square meters. Basically, the facility manager, they operate the whole system, and then the owner for each unit, they pay based on the square meter.
Or only on square meters, I think. That's exactly the question, because on the other side, the split unit, you pay with your electricity bill, because this is really individual,
Yes.
while the central system, which goes by square meter, you say, if I do it with an open window, I don't pay 1 cent more if I just...
Yeah.
Yeah, no, but
Yeah, no,
I think that's a
yeah.
very important point.
Sure.
So that's why we think about sustainability. We think about this sustainability is combination with three parts. One is market, one is customer, and one is energy bill. Because the market is come from customer, and the energy bill is also come from customer. So we should know about the customer behavior, and also we should make the customer to know this building well, and then they can easy to control and use the building more reasonable. And also, if the customer can feel the benefit of sustainable building, they can buy this building again. So I think the sustainability is not only the energy saving, but also the long-lasting usage of the customer, and also the recognition from the market. So the customer in our words is also means occupants. So that's what I just said. The occupants should need to know and operate buildings well and achieve the sustainable green. And also, we should try to make the occupant feel the difference of sustainable buildings. Because now some people say the green is inside the wall, and nobody knows that. Because the green is a long term, you should make the people to know this green building truly works well. And then this will make customer to buy and recommend this green building again. And this will achieve sustainable commerce. And on this combined together, I think this we will really achieve the sustainable building. Okay, then is what we want to do. In the last 2 years, the Chengdu regions of Vanke developed a new series of happiness series. And at the beginning, there's two background information. One is our main customer in Chinese residential market is first buy, or the first buy piece. First buy means it is the first house for the couple, and then the character of this first buy people is that within 3 to 5 years since his new home, his family structure will change a lot, change seriously, because once they buy a house, they will have children, and in China, his parents or her parents will come to his house to live with them, to develop the children. So at the beginning, they will only have 2 persons in the house. But in the coming 3 to 5 years, it will become 4 to 5 persons inside this house. So we will think about how to design a house, how to design this layout to get used to this sharply change. And also this first buy person, it will take close to 0.5% of our customer share. So this is our main customer. So our product is designed to satisfy these first buy people. And also another background is our community. In China, we are, as I said, the fastest urbanism, and you will see we will see many high-rise towers similar to Hong Kong, but our case is better than Hong Kong. This is the case in Chongqing, and this Vanke city also the cloud ratio is higher, is more than 4.0, and this high density per floor. Each floor they will include 6 to 10 families, and overall the whole communities, the densities around is 4.8 person per 1,000 feet square. And normally each our community will just we have more than 10,000 people live inside. So for one community inside is quite high density. I think there's some difference with some Western country, but in this developing countries similar to some country in China or some Asian countries, we are experiencing these enclosed communities. So people will just share a community together. And then we will experience less land, and we should make a high tower around this community to absorb as much customers as possible. And so what's the purpose about the happiness series? We should provide more functions because the family need to change in a short times. And sure, we should achieve more function with less indoor area, because the total cost of the Chinese resident market is quite higher, and it's quite expensive for young couples to pay for new homes. So we should make the less indoor area, and with that less payment pressure. So this is our key values. We want to develop good and affordable apartment for a common person. And the good means the good performance, and that is a sustainable building. And affordable means smaller indoor area with low total cost. So normally the layout of each family is around 60 to 90 square meter, and the common person we think about is this first five person. So how we can decide good house? This is a very famous formula, and see how the energy consumption comes from. And this P plus S and plus E and plus C. So this, as a developer, only the E we can try to do it, because we cannot reduce the population, and also the persons to use the equipment will increase also fastly. And the carbon dioxide per unit energy is controlled by the government. So what we can do is we can just reduce energy per equipment. They included with less time to run equipment and less energy per equipment. Less energy equipment depends on the market level, because this is belong to some manufacturer or big equipment company. And also we will depend on available, affordable, and accessible. So only what we can try is to try to make less time to run equipment, and we think this depend on occupants' behavior. So less time to run equipment also include two parts. One is active design and one is passive design. Active design, we can use many sensors, database, and just HMI, IoT, Internet of Things, and make people to know environments very well. And this HMI system can tell people what the environment it is, and the people can change the environment by the IoT. And also this is very future system to just make our home more smart. But at current stage, as a developer, it's hard to achieve this active design by this complicated system. So what we can do, we will try to use some more passive design to make our house with good performance. And in this chart, you can see this performance from low to higher, and this is cost from low to high. So this is our local house many 100 years ago, and so now it's still working. But this is low performance and also low cost. And we can do the high-tech buildings similar to Highest Tower in Abu Dhabi. We can use high cost to achieve high performance, but this is quite expensive for us to copy everywhere. So what we can do is we try to use passive skill with low cost. We will try relatively higher performance. The performance similar is simple. It's warm in winter, cool in summer, more daylight, more wind, and less noise. And surely some case we won't consider, because you just pay a lot of money, but actually the energy bill is not that good enough. So we will try to use passive design to achieve such value. And passive design will include the interior design and exterior design. Interior design, later I will introduce my colleague Mr. Martin, introduce what we decide this layout by the occupant behavior in 24 hours. And also we use passive design skill according to the local climate and learn from the local residents. And surely we'll talk a very important part is exterior design. It's outer comfort. Because under such urbanisms, more and more people move into a high-density, high-rise town. The people will have less spot and less width. So in China, there you see many fat boys there, and also the lonely elders always stay at home. So we need a space for people to come out to play and just talk and chat. I think this is a future brand of Vanke should make the people to feel the Vanke community is full of love and full of some happiness. So we hope to make people come out to share their experience and just less time inside. Because in our mind, the more time you spend outdoor, the less time you spend indoor. And that means the less chance to use the equipment indoor. So we want to try to put the people out. At the beginning of describe how we design for interior, we want to share great words from IDEO, a famous innovation company, to make very remarkable design. For example, like the mouse, and from Apple, also designed by IDEO. And this is a famous sentence because all the innovation is from human, is from the practice you know from the people. And we are the people, and also our product are inspired by the real people. So that's why we focus on the occupant behavior. So I want to spend 5 minutes to introduce my colleague, Mr. Ma, to just give a short introduction for his design for this layout according to occupant behavior. And Mr. Ma is our chief architect for this happiness series. Thank you.
The same name of the Massachusetts, so I'm proud of this. Okay, thanks. I'm only just 5 minutes, so I think it is easy. As an architect, I want to find a different method of design. So this method must be in truth, must be in fact truth. Not in feeling. I think the feeling is wave. So the next 3 points is the method of design during my work. The first is space overlap in 24 hours. I think that I can find out the space problem by space overlap in 24 hours. In this sheet, I think this axis is the time. The time of 24 hours between the 7 o'clock morning and to the other day 6 o'clock. It's just be 24 hours. And this axis is the different people, such as this is old man, this is child, this is we between all the behave in the 24 hours in this. So according to this sheet, we found the actions all of the 24 hours, such as the washroom, we can find the common case. The common case of the washroom is very busy. So we found this way. The color is very dark. Very dark is such as the very dark is so we divide the washroom as the toilet and the shower and the washing face between the two rooms. So we found we need the space for 3 or 4 persons to use the washing room at the same time. So it's the result of the washing room. All of this is the result of overlap in 24 hours. This is one method of design. And the second is cold range. So we use the this is the model of cold range. This axis is the customer importance, and this axis is the customer satisfaction. We found the first dimension is the basic demand of customers, and the second dimension is potential demand. So we must focus the dimensional demands. The method is we list all the demand of principal bedroom. So such as bedroom. The principal bedroom, we list all the demand of principal bedroom, and we designed a questionnaire to the customer to score. So the score number, we list all of the demand in the different quadrants according to the scores, such as the king size bed in the first dimension, so it is the basic demand, and the makeup space and the baby bed in the second dimension. So we will focus the makeup and the baby bed in the bedroom. So this is the result of our bedroom of principal. So it's this the result, and this is the before. So this is the second method is quadrants. And the third method is I named it as radar chart. In this radar chart, we divide the six dimension, such as about efficiency rate of indoor area or outside area or public area, or about the daylight performance. So we can find the advantage or the disadvantage of the variable layout in this chart. We can clearly find the advantage or disadvantage. So all of this is the three methods of design. So I did this method can help us to in the design of my work. Thank you very much.
Okay, thanks, Mark. And here is our three main methodology to design our layouts according to the occupant's behavior in 24 hours. And we use the quantitative analysis method to just do.
And my English is very poor, so any question can be answered by Mr. Zhou. Thank you.
It's okay. My English is good enough. And this
you should hear our Chinese.
Yeah.
I want to say Chinese.
It's terrific.
Yeah, we should use we want to try to use more reasonable thinking for our design, and not only just by a flash of our mind. And then we try to use some methodologies to evaluate our products and also evaluate our design. And then also we will back to a case in Chongqing. And Chongqing will tell how we use passive design and make our buildings more friendly to the local climate. Here's Chongqing. And Chongqing, they're a very interesting city. Some people have been there, and that's quite hot. We met there, the spicy girl or spicy food. And the reason why they're so spicy there is a few wind. There's a few wind there. You can see that the wind per meter per second around the year in Chongqing is quite low. So they will just, and also you can see the city is sitting on two rivers. So the humidity is quite higher, and you see the high temperature with high humidity and with less wind. This will rise a very severe problem of the boiling system and make the people feel stuffy. And then we want to try to learn from the local residents, see how we can do that. And this is very traditional house sitting along the sea and raise the floor and then make the cool winds come inside. And we try to our buildings more transparent. And also, this interesting village, just sitting aside the river, and we can see open and close, open and close, and they can easily absorb the cool winds at night and make the winds come inside this village, and this can make a lighter cool air in this microclimate. It's also to this high-rise building, because Chongqing is a mountain city. They use the difference of the height and just use the buoyancy effect and try to make this cool wind come up from the bottom. And you see all the floors wet because this wind is more humid. And for this layout, we also use this close, open, close. We use the change of the section area, and then also make this wind pass through all the buildings, make the light transparent. And by safety model, we can precast this wind conditions inside this layout is quite good. It's normally more than 3 meters per second. It's good enough to remove the disease or something bad smelling away from the buildings in less than 2 minutes. It's very important for public buildings especially. And also we use safety model to make all the towers getting wind by suitable orientation and form. Because as I mentioned at the beginning, in China we will have fast urbanism and also with many high-rise towers. For example, this is one community with 6 high-rise towers, around 100 meters and around 33 stories. And then we should just decide the orientation and forms of these 3 buildings and see how we can achieve the best form of these 6 towers, and they can guarantee this tower can get a suitable wind. Because the constant wind from all around the years come from the north. So this tower should be very careful, because this tower is after 5 towers. So we just change a little bit around these angles, orientations, and get the better pressures on both sides. A better pressure means they will have more potential for the natural ventilation to come through all the building. And then we can each the living rooms will achieve more than 30 times air change per hour if we just open a window and close our home door. And this will guarantee all the apartments, no matter face the wind or opposite the wind direction, we can get a very good air change conditions. And for most malls design, we think about these bedrooms. And these interesting phenomena happen in Wuhan, and also the same latitude to Chongqing. And this happens maybe 10 years around. People sleep outside the door, because at that time the air conditioning is not that popular. So the people sleep outside on the bamboo. And this is very cool and very interesting. People can share their stories with very good neighborhood. And even at the morning, you should have some sleep to just calm, because at the morning the temperature of the air is quite cooler compared with the indoor air. So you want to try to use this lower temperature outdoor and for this natural ventilation at night. And so we open a window here. Also, this window can provide good daylight for this makeup desk. And also, when you sleep at night, you close the door of the room, and this open 2 windows. This can achieve the cross wind. And sometimes they will get in specific season, like past season, like spring or some autumns, it can save energy. And that is a good case for the energy saving by occupants' behavior. Because at some season night, you can just open the window and just also with the door opening out, with the door closed for privacy, you can also achieve a very nice air conditioning inside this room. And this can save, by calculation, we save over 20% of air conditioning time per year. And this is what is the case for energy saving by occupants behavior.
Do you actually suggest different permutations of windows, doors at different times of the day to occupants? Or is it something they determine empirically by opening doors and closing windows?
Yeah, we will just suggest them to we have to make a culture to tell the people when to open the door and when to close the window. And then to make the people to know this building well.
And is placement of furniture important in that airflow?
We haven't considered the furniture.
Okay, yeah, thank you.
Because the furniture is designed depend on the occupants.
Yes.
Yeah. And by some small scale, we also use this specific skill to achieve more better daylight, also according to the occupants' behavior. For example, in this washroom here, we want to have more deeper daylight for the face washing. So we use vertical opening, then make the daylight come more deeper. Then can easily for children to wash the face without switch on the light. And also for this toilet rooms, because people will read the newspaper and also magazine, so we need to ensure the daylight span. And then we use this vertical window to guarantee you can see the place you want to reach. They want to read the newspaper can get enough daylight. So we just design our daylight also according to the occupants' behavior. And so for the outdoor space, we use some technology from safety, and this is Raymond from German, I think, yeah. And use this software to recast some comfort level for outdoor, according to this safety modeling and also the daylight and radiance. Mrs. Ray Yi will introduce this later, more further. And the reason why we want to consider this outdoor comfort, because we are losing some good memory in our childhood, and so we want to just ask more children to leave this high tower to come out to just share their happiness together. So we decide these play zooms according to this safety and this software analysis. For example, this is different zooms inside this community, and also this is the whole day from morning to afternoon, and on around Zoom, and see the comfort level for different persons, including elders, children, and adults. Then we can know which place is more hot for the children and which place more suitable for all the family to play around. And finally, we choose this place with better locations, and then with enough shade and suitable sunlight and also the suitable wind. So we decided we can make our location more reasonable according to the safety and daylight analysis, and guarantee that people can just play here without too hot or too cold and with suitable wind. And this is what we want to achieve, this outdoor comfort, and make more comfortable room for people to play around. And this is what I want to say. We want to get some memory back, because we are losing some happiness which happens and occur in our childhood. So we want our community to full of love and happiness in the future. And then we make further research on community environment. And we require this more outdoor and less use of plug power. And then later Mrs. Yi will introduce more interesting story in our Wuhan residents community. And we do some research on the different rooms and see there are many interesting results. And at the final page, I want just to emphasize our views for sustainable future, because the happiness of community is the brand of development. And also there are three key issues. One is affordable with low tech, because high tech sometimes means high risk. So for this such biggest developer, we will try to use low tech and more just low tech and for easier for people to afford. ensure it should be real green by the energy bill. And then the last is health is priority for us, because sometimes we can buy the comfort, but health we cannot buy it. So in the future we want to just think more about how to make the environment more healthy, not only just think about health. So this is the last word for my presentation. And this was getting more from less for more. This is a good sentence from R&D engineering. People can just check this word on the logo. And this is a good word for our sustainable design in the future. Okay, thank you very much.
So I think we are going directly to Keith's presentation.
Could we send someone to run for water? Could we have volunteer? I'll pay. No volunteer? Yes, perfect. I'm doing that at home. At least for 6, how about 6 bottles of water? Yeah, or I mean,
It's a type of question.
Yeah, we thought we should do it in the discussion. Maybe if you have, we take 5-minute questions. Yeah, I would say yes.
Okay. I think you made a really valid point how important it is really that we can technologically produce comfort indoors, but getting people outside comfort is good. I think you made a great point there. And you've shown that we have solar radiation analysis and wind analysis, so we have all these placeholders. And you've done some measurements now, seeing when people are outside, have you connected them? I mean, there are dozens of formulas that try to predict outside comfort, but we really need one validated method that we can basically, based on solar radiation and wind, say people will be confident in that. Can you make any progress on that point?
No, so far there's no program for that, but we try to just use something index. And Mrs. Jiang will introduce later how we can put the index in the formula. This formula maybe is just for a specific location, a specific city. But nowadays, so we don't have program, we just take it ahead.
But what do you use right now? When you showed us the CFD analysis and the solar radiation analysis, so how do you determine if it's comfortable or not right now?
Right now we use some classical level for these elder people and also the children. Some are the comfort zone from 18 to 26, something like that. Yeah. Use some classical. Maybe we will just make some small adjustment in the future. With different conditions by the activity.
But these formulas are for indoor comfort, really, and in a way you're expanding them to outdoor comfort, isn't that?
Yes.
Yeah, that's, I think you used PNV, which is only PNV, and we had it this morning in the lecture, or yesterday in the lecture. It's an indoor comfort rating. How I will, you may want, but I will show it how PNV can perceive. We are using perceived temperature in a certain way, and perceived temperature in this case, I say pretty simple. It allows people to sweat, because outdoor you can allow people to sweat. Because you may have wind to increase in a certain way the evaporation, while indoor sweating is already out of the comfort range.
Yeah. So perceived temperature is operated temperature, is it?
No, perceived temperature is more or less a rated PMV. It's a rated PMV which in a certain correlates the perceived temperature to a certain condition of someone at with certain activity at certain exposure to temperature, humidity, velocity. So it's a comparable temperature you can achieve at certain outdoor conditions. And it may depend, and it really depends on solar radiation, wind velocity, activity, humidity level, air temperature.
Is that the same that the Weather Channel uses? If they tell you basically it feels like...
Wind chill, they tell you wind chill factor.
no,
Including the wind chill factor. No, measured in the wind. It's, I would say they are not so scientific.
They give them way too much credit.
Yeah, just in response to Matthias and your question, Christopher's question. At that time, actually, we first started with PMV. There are kind of some modified PMV, and with by allowing natural ventilation can be considered. And then we also tried the perceived temperature, and also because that time the design phase expired, so we also use the river model and develop a Germany, I think, a research group. So by considering solar radiation, but the basic idea is very similar at the same temperature. So they have two different models to consider outdoor comparable comfort at that time. But the second question in response to your question, at that time it's only for design, as you can see from Chongqing's presentation. That's for, thank you so much. For design in a Chongqing, that's for new community. So you don't really have a real data to validate your model. And my part is more like a research project, actually, in response to their techniques series or their philosophy, we want to really understand in the existing community area how important the outdoor thermal comfort is. Does that really affect occupants' behavior? For example, how long they can stay outside because this is comfort, and how often they would come outside, and how many people would be staying there. So that's a part will be here.
Okay. So let's go to lecture.
Any questions?
Yeah, but I can wait for later if you prefer. So
One short.
okay. No, it's more about the indoor, but you do all these simulations to try to design your buildings in order for the user to be able to adapt to different conditions and kind of control what they are doing, and then produce this brochure or whatever to give them the guidelines to perform their building. How? But are you doing a follow-up on the different projects you do? Like you know if people do or they don't do what they're supposed to? And do you have to kind of work on that, or do you just keep to do it and forget about how they are doing?
We will make some measurement for the measurement this year, because the design, the timing from design to finish and people to move in, a long time, maybe 3 years. And now we will have some experienced buildings, sales room, and make the customer come in to feel the room before they pay the money for the house. So inside people can just feel the transparency of the house, and also the window I just mentioned. Before they close the door of the bedrooms, they also can open two windows on both sides. This also maybe there's outside and no wind flow, no ventilation at that moment, but the customer will just feel, because transparent, they will have also this equal to this. It will be wind, right? If the transparent will sometimes means that we should some wind will coming through. So also this customer will just feel in the future it will experience a good ventilation. Also we will just measure this building when it's building up.
Yeah, well, what is very interesting is certainly you call now this cross ventilation certainly occupant behavior. I would call it design-based, because in a certain way, to give the customer, the occupant, possibility to do cross ventilation, this is design dependent. This is not occupant dependent, because if he buys the apartment and it doesn't help because there are not enough windows to do cross ventilation, he can be trained to do it, but if there is no possibility to do it, then this is so. Therefore, I would question your strong emphasis to say cross ventilation is occupant's behavior. I would say it's both. First, you have to have the possibility to do it, and then you have to train the people to do it. But most of the buildings, I think, in China today, you can open the window, but there will be no cross ventilation because they are not at a corner, or you don't have the connection for the air to room.
That's why we decide. We provide this condition for them, and in the future we teach them to do that.
Exactly. Okay.
All right. So let's move on from indoor to outdoor, and to share some data with you. So I first talk about the problems, the properties, and our research objectives, and then the methodology we've been using to do our study, and share some results and analysis work with you, and then provide the conclusions and next step. So you've seen these pictures shown by Chongqing. Actually, this is a residential community in Wuhan City, actually operated by one Ke. So this is actually two spots inside the community area. One is the children's place, which is a playground. The other part is basically empty square with one table and a couple of chairs there. So in the summer morning, actually this playground is fairly empty, and here is just a dad and a young kid. But in this area, you see the Chongqing Square area, there are normally over 10 people staying there, chatting, talk, and playing there. And in the fall morning, it's on the country. In this playground, there are plenty of people, full people are occupied there. But in this Shandong Square, nobody's there, except for our weather station actually later on installed there. So this is not just happening for one occasion. We took picture, we intentionally doing that. Actually, this is happening every year. This community actually has been there for over 5 years. So actually, we got this actually a story from Guangke people, and then we actually went there and observe this phenomenon. So basically, the idea is more like, occupants will design this area, place ground. You hope people can go there and play there. That's actually as a question. We will do the later survey. You found it's not necessary. People, they don't really necessarily go there. What's the difference? Why the occupants would choose the different behavior by using different functional zones? So the main reason, actually later on will be introduced as well. This area is basically there's no shading. And Wuhan is a very hot and humid area, similar like Chongqing. So in the summer, there's no shading. It's very hot and humid in this area. So nobody would go there, even in the morning, it's very hot. But this area actually is very well shaded by the 2 tall buildings. And also there's a good ventilation across the channels. So basically people stay there, they feel very comfortable. But in the fall time, actually here, the weather, the temperature drop down and you feel comfort there. But here, people will feel a little bit cold, so you don't stay there. And also there's nothing you can play there, basically. So you provide the functional facilities, but the temperature, the thermal comfort doesn't provide the good results. Doesn't provide the good condition, and people will go there. So that's actually this was our research objective. We feel it's more like the outdoor space quality, such as thermal comfort and functionality, safety, convenience, would affect occupants' outdoor activity level. When we talk about the outdoor activity levels, that would introduce like the usage level of the zones. For example, how many people will stay there, how long you will stay there, and frequency of the attendance. But also, what's your activity type? Do you just go there, take an individual work, or you really want to go there with a group of people doing something, like China, they want to dance together. Many old people, when they retire, they actually dance. So can you really do those type of different activity levels there? If you can provide this good quality, that may be help to improve your outdoor activity level. And then later on, like what Chongqing actually mentioned, that would help actually to build a community closeness, to improve your actually community loyalty, and maybe to talk about the happiness. And since we started this work last summer, so our research emphasis more like on this area with specific data actually from the thermal comfort correlations with the usage level of the zones. First, talking about the some kind of theoretical models we've been using. So basically, the first one we've been talking about is regarding the occupants' comfort, thermal comfort. So instead of kind of doing there's another way to do the occupants' outdoor thermal comfort based upon your measured meteorological data as well as the occupants' sensation voting. You ask them whether they feel comfortable or it's too hot or too cold, and then you correlate your wind data, the air temperature, humidity, solar radiation, together with your sensation voting, you get ASK, actual sensation voting. That's actually we've done the research, we've done the experiment measurements there in the Wuhan community. The other one actually, the model we actually developed is a zone usage rate, the functional zone. You have a different zones for people to stay there. So how many people will stay there? Basically, your actual number of people stay in this zone divided by your maximum number of people, the capacity. And then this usage rate is really a kind of function of your thermal comfort, your functionality of your zones, and also like the occupants background, many other issues. So basically, our study, our experiments and the data analysis really based upon these two correlations. And regarding the experiments, we set up actually 2 weather stations, just exactly like the two pictures I show you. One is in Shandong Square, which is an empty place without any play for two sides, but just it can be very comfortable in the summer. And the other one is a children's park, in the playground. We set up another weather station to measure the air temperature, humidity, wind speed, and solar radiation. The data is continually monitored starting from last August. And in addition to the microclimate data measurements, we also done the occupant survey and record. So people actually, we surveyed more like 3 groups of people. We divided the surveyed people as elderly people, adults, and kids. And also we observed their kind of typical activities would be 11 types of activities. You simply sit there, you babysitting, or you dance, you play with others. So they are kind of different activity types. And also this is a community area in the Wanke, Wuhan. And we choose, basically we covered all of the central, the activity zones, like the children's place, like the Shandong Square, or some other plaza, some other plazas. So basically there are 6 areas we actually have done the research surveys, occupant surveys. We choose 4 different time periods, which you can see the occupants staying there, early morning, afternoon, and evening. So since from August to December, surveyed over 400 people regarding their thermal sensation voting, how they feel, whether they feel comfortable or not. And also, besides the survey, talking to the occupants, we also kind of done the observation to record in different areas how many people will stay there, play there, what their activity look like, and how many elderly people and adults. So we also do the report. And based upon the measured microclimate data as well as the occupant sensation voting, we developed the ASV model for the Wuhan actually. So this is actually your comfort is related to the temperature, solar radiation, wind speed, and humidity. And we also did a very interesting comparison with another ASV model developed by a group of researchers in the UK, Cambridge. So this is the other ASV model by them. So basically, if ASV equals to 0, that means you feel comfortable, it's neutral. If the ASV is a positive number, the higher, that means you feel hot. 1 can be hot, 2 can be extremely hot. And if it's -1, you feel cool, and -2, you feel too cold.
Is ASV and PMV the same? The Funger predicted mean vote would have a similar equation.
Yeah, this Funger's model is based upon his indoor statistical indoor measurements and surveys, and then he devised a model. That model is really kind of how do I say it, the semi-theoretical model. This ASV is nothing to do with semi-theoretical. It's really based upon your real measurements of outdoor people's comfort. So that's an empirical model. So, but most time, if you don't have this luxury by doing this type of surveys, you have to borrow some PFV model and make modifications. This one really based upon experiments, how people feel about that.
So, I have a question.
Sure.
The model is listed in Wuhan. That's actually running regression against the meteorological data collected on the 2 on-site weather stations. So actually, it's you're assuming that the zone or different square, they have a homogeneous thermal conditions for people whoever is using the square, or you actually go down to collect the microclimatic variables.
Go down to the microclimate.
So you have like a portable weather station that actually measures.
Yeah, exactly. So here is more like we compare the Wuhan model and the UK model. It's interesting. It's more like the red color is for Wuhan and the blue color is for UK. So you can see when the same weather condition, same air temperature, same solar radiation, people in Wuhan would feel comfortable 0 or to 1. But under the same weather condition, the people in UK would feel too hot or extremely hot. So that's the kind of condition is more like this kind of model really kind of depends on the which region you are coming from. And the people in Wuhan, how humid weather, they get used to that weather, so they can tolerate the higher temperature condition.
Yeah, that's interesting because certainly that's certainly the absolute, I would say, contradiction to the PMV. The PMV is independent from the voting of people in respect of indoor climate is independent from location on the street. That was one of Funger's conclusion, and I would even say comparing people indoor. In Europe, in UK, people would accept indoor 26 or 27 degrees. People in Wuhan or in Hong Kong would never accept 26, 27 because they would rate it as too hot. So it's just the other way around. That's why Europeans traveling to Asia are nearly killed by over-freezing spaces because we are not trained to come in a room in summer where it's 20 because it's typically 24, 26, 28. So it's kind of that outdoor it looks like people accepting as it given, then indoor because they're connected to machines, they take it then as given that it's colder, it's clearly colder than outside.
I think the best part about Funger's model is really kind of to identify the parameters that really affecting your, first time to raise the question, how do you quantify your comfort with those parameters. But later on, based upon Funger's model, many modified PMV model have been developed just to justify different regions, different people. And like Funger mentioned, the dry and the cool air, under that condition is the most comfort condition. And then many researchers from, like South Asia, they would agree with that. And so by doing the study, we actually found some very statistical numbers which are also interesting. Like in this community area, there are a total of 11,000 people, actually a very large community. And among them, there are 56% are adults, and elderly will be 25%. But if we look at the outside occupants composition, actually there are 2,300 people actually on a daily basis to go outside. So basically 20% of people go outside. Most people will stay inside. And among these outside people, actually adults is only 30% and elderly would be 40%. So there are more elderly people going outside, stay outside. So if we actually divide for each age group, we kind of divide the outside activity people divided by the total number of that age group people, you can see for adults, only 10% of people would go outside to do activities. And for the elderly and the children, 30% of their age group would stay outside.
Is this now the mean value over the day, or is it on a specific time of the day? Because I would conclude the adults just have to go to work. They have no time to go outside.
This is a mean value.
The mean value. So that's the main reason why they cannot go outside, because they have to go to work. So it's not, it's a bit, I think it would be interesting to say why, if you do this rating at 6 or 7 o'clock in the evening, when everybody is home from work, or whatever, or on a Saturday, where suddenly everybody has the chance to go outside, maybe the numbers would be similar. Because this intends that children and elderly people want to go outside and adults want to stay inside in front of the TV. Or whatever.
Actually, there are some, definitely, since the time is limited, so I didn't present many other results. Actually, even during the evening and during the weekend, the majority of the people stay outside, still elderly. Adults tend to be, if they stay, for example, during the weekend, they just travel car, takes their family, go outside, rather stay in the community.
Is an aspect of that perhaps that the elderly are trying not to be as intrusive in the primary environment of their children or relatives, or might it be they just want to socialize more together outside?
Socialize. That's the kind of culture of Chinese community. Elderly, when they get retired, they actually form their own kind of group to dance, to do the group one, to do many other activities together. So they tend to stay outside and be close to each other.
Given the opportunity to socialize indoors in the same way they do outdoors, would they do that in the winter in a similar fashion and spend as much time socializing in an indoor area?
ask the bank whether they can provide large enough space. I think the
Yes.
space is also a problem.
Right. Yes, thank you.
And also the other thing, like, when they go outside, the lasting time, how long they can stay outside, the elderly definitely is more longer than the average. And they go outside more frequently than the average number as well.
Tai Chi? I'm sorry.
So the other part is more like, once we got all those numbers, the statistical numbers, we actually try to devise some models or correlations between the ASV, your comfort, and also the correlation with the actual usage of the space. For example, for this children's place, we have the weather data, so we know what ASV should look like, and then we count the numbers according to different weather stations, how many people will stay there. And then we do the normalize the average zone usage rate, for example, the percentage. This is more like you have maximum people, 100% of people actually would stay when the ASV outside is comfort is 0. And then when it's getting hotter, and less people will stay outside. It's the same when it's getting cooler, less people will stay outside as well. So that's basically the trend of this. So this is based on the record data. The same for the Shandong Square as well. We have the data as well. So we can develop this kind of normalized average usage rate of the different functional zones. Actually, there are some interesting findings. I don't want to talk about this is very linear, simple formula. But the interesting part is more like the blue line is for children's park, and the red line is for the Shandong Square. So we can see when it's comfort outside, it's maximum people will stay in that room. But when it's getting warmer, for example, 0.5 is you feel warm. Actually, in the Shandong Square, you would have maybe 60% of people still stay in there, but you have 70% people will stay in the children's park. So basically, the Shandong area tends to be narrower in the children's place because that area you have nothing to provide, just stay there. But for children's place, you have more functional facilities provided. So if you can provide a comfort area and you have many functional facilities, people will tend to stay there for longer. So that's with this measure data.
Having small kids, you go to the playground even when it's raining, being happy to get them amused.
You must stay there longer.
Yeah. But we actually also, by using that kind of model based on the measure data, we actually try to expand that study to the whole year. Actually, for example, for the Shandong and the children's place, we found the air temperature is very similar in those two areas. You would predict is more like in the children's park, there are about 3 months actually, you would feel hot. The ASV is larger than 0.5. And in the Shandong Square, you would only feel hot is more like for 2 months. You basically, without good design, with good design, you actually help to reduce your outdoor discomfort of time by 1 month.
Okay, but in a certain way, isn't this, okay, you now proved it by measurements, but everybody, if you had asked me, I would have told you that an unshaded playground is less occupied than an exposed, than a shaded one, especially in a hot and humid climate where, in a certain way, the solar exposure is one big issue in respect of comfort. So the question, in a certain way, okay, I think it's a nice proof of a certain kind of basic knowledge. We know we should design outdoor playgrounds in specific climates to react on the solar exposure or on the wind exposure.
The questions are generalizing the data. So if I understand that you had about 500 people that you surveyed, and based on that you came up with this formula?
Yes.
And how many people did you measure occupancy for? More people, a lot more people, I think.
Occupancy, yes, more people. Actually, we surveyed, for example, 500 people. But when we observe, for example, like I stay here, I just observe there are total 20 people here, I observe that. And their age group, I just report that. So that's, we also
I mean, the one thing is you basically have to say an overlap between the sample that you use to derive the formula and the sample that you actually really try to make the point that your model predicts what's going on. I mean,
actually, that's in parallel. You use partial data to the model, and then you use another partial data to, that's kind of comparative analysis.
I mean, the question always is how general is that data function? I mean, I agree with Matthias that we have somewhat cultural specific functions.
Yes.
But we can't in every project do this experiment, so we somewhat have to come up with maybe some regional or country or ideally climate specific.
Yes, absolutely. This really depends on, even in China, it depends on which area we're talking about. You know, if you're talking about this area, there are little shading people will love that. But if you're talking about the northern region, I love the sunshine. So if the first time when I went there, I saw people don't like sunshine. Even in the winter time, they don't like it. I don't feel, I feel very, very strange actually. It really depends on the region. That's why we cannot really use a universal model, or universal design rule apply to everywhere.
During some of the recent hot summers in New York City, it was discovered that playground equipment elevates temperature considerably depending on the equipment. For example, in Manhattan, it was discovered that recycled tire safety matting was causing second-degree burns in children on their feet because it was exposed to sun and heating up unbelievably hot. The same with artificial turf, where in New York City they measured 160 degrees on a normal summer, a sunny day around the fields that was then radiating outward from the fields to create an envelope of heat. Is that something that you had factored in here between the children's park and the square? Is it possible that one has equipment that's heating up more than the other?
Actually, for this part, there are some majority of the equipment actually they are more like a built with the wood, I think. Not really wouldn't cause the injury problems.
Yes.
But some areas that can really be very hot in the summertime.
No, but I think normally in the equation, and you will see it in my presentation, we take into account what kind of floor, what kind of absorption on the floor, what kind of capacity you have there to take into account even this kind of capacity during daytime, but as well then into the nighttime. Because if you have a massive, high absorptive floor, you will read it at midnight that there's still some heat coming out of it. If you have a very thin floor with no capacity, it heats up fast. So at daytime you get a problem, but at nighttime it cools down fast. So at nighttime it improves.
Yes.
So
absolutely.
At that point, I think the long-wave radiation and the surface heating caused by solar radiation actually is embedded in the residuals of this regression model. So the ASD is a statistic model that probably has an R squared of saying its prediction power. I don't know, you didn't list the R squared of how well that matches with the
but what's the sky temperature in there in the equation? I didn't see it.
Well, I think the ASD model has only listed solar radiation, humidity, wind, and temperature. And then it haven't included the surface temperature. But I think for other thermal comfort metrics, the PMD, for example, actually you have to take into account the mean radiant.
Yeah, no, exactly.
So that have to take account everything.
But that one actually is more suitable for the indoor. We also talk about the indoor, the surface temperature won't be that high as outdoor, like the indoor housing. Anyway, that's a whole kind of theoretical discussion.
No, but I think it would be interesting to say even at SAB, you should maybe include the mean radiant temperature. You can define a mean radiant temperature even for outdoor.
Yes.
What do you want, drive-up temperature? What do you measure, drive-up temperature or operating temperature? You could with your little report what is
white bulb temperature. And some other factors, I know probably timing will not too much. Yeah. Some other factors we actually started, like, besides the how people would filter, they are outside. When they go outside, why they would go outside, So they will actually, the outdoor environment is their priority. If the area is very comfortable and without too much noisy, they will just go. So there's 60% people who choose by that. Actually, when we show this result to bank, they feel very surprised because when they try to sell their property to the owner, normally owner would more like to see what's your functional equipment are. But when they really stay there, live there, So the priority they want to go outside is really big for this. So some others, like interaction level activities, when people are doing more like a higher level of interaction, like this type of social activities, they are more sensitive to thermal comfort and facility functionality. So if it's not comfort, they wouldn't go outside. So if you want to improve their social activity level, you have to provide a better outdoor comfort and better outdoor functionality to them. So this is an example picture. In the summer morning, it's very hot and nobody will stay there. This is something other. But if you actually in the fall morning, it's comfortable, and then it's basically hub of the whole community. People stay there, dancing, babysitting, talking, and all activities would happen there. So that's the reason for that. So anyway, so some kind of quantitative and qualitative study has been conducted, and provide some kind of guides to designers and operation personnel how to create a good quality outdoor environment and associated with the activity level. So for future, we'll still continue such kind of study because only half the data won't actually really can provide a better solid model for us. And also, we are actually thinking about these three elements. We are actually not just working on those two elements, how that can be improved to the occupant closeness can be correlated with that. Some kind of study can be also performed. And also really kind of to think about the community social network. There are a lot of interesting phenomena observed from this type of community observation and record, and hopefully to improve the residents' satisfaction, loyalty, and safety.
The corollary to this is the 80% of people who don't go outside. Did you make any attempt to find out why they don't go outside, or what it is they would like to do if it were available to make them go outside, to entice them?
We actually set up a plan for that and try to, yeah.
This was plan B, okay. Thank you.
Yeah.
No, I think, and what is as well quite interesting of your last point here, because Chongqing mentioned that the target in a certain way is to go for smaller apartments. And one of the findings we had for the master plan for Paris in 2030 was we have to reduce the individual living footprint in respect of sustainability because we have not so much space for people. And you did it out of economical reasons that people don't have to spend so much money to do it. But reducing the indoor area is increasing the pressure on outdoor area, on the quality of outdoor area. Because if you cannot stay so much inside because it's so tight, so small, you want to go more outside now, then the quality and the outdoor comfort becomes even more important.
Exactly.
So you're moving to turn-of-the-century tenements then, where there's no daylight, no ventilation, no windows. You force people outside.
That would be too brutal, but in a certain way, the Paris numbers are, in the 50s they had 25 square meters per person. Today they are at 45. In 2030 they're expecting 65 square meters per person. And in a sustainable matter, we have to get the 45 back to 25 or 30. Which in a certain way we can learn from South Asian countries where, like in Tokyo, you are down to 20 per square meter. So in a certain way, or even less. So in a certain way, but what does it mean in respect then of on an urban level? Because one of the findings was, okay, if you squeeze people, and there are some banlieues in Paris where the density is so high that they are below 10 square meters, but then the social pressure is so high that you are in danger to get really street fights. Because then the density, if then the outdoor spaces are not, in a certain way, creating the balance for the tight inside, you get a social problem. So I think therefore your point that you're achieving to get, in a certain way, that the apartments get smaller is then out of this point, I think, very strongly related to this outdoor comfort. Because if you live in a smaller apartment, you have to go more outside, otherwise you get crazy.
But you have a level for this condominium size or indoor, because now the why do we have this? Because total pavement pressure is quite high. It's quite expensive there. So we should make the indoor area relatively smaller. Then the total price they can afford. But you cannot just raise a very small area. Nobody will buy it. So it's just relatively smaller, but not that too small. Around here is 60 to 90 square meter of a family.
My interest is
I have a problem with the social engineering, but I mean, apart from this, I think it's important to create spaces that are comfortable. And I think this is very relevant research. I would really like to understand how these individual, because we end up with these individual formulas for every city, and that's not practical. So if you look at your formula and you compare it, for example, to the Fangler model, you just fit the Fangler model, how much of a difference do we talk about? And how far do you think we could just start implementing sliders or so? So in your consultancy firm, you basically say, the Danish Fangler extreme is here, the Central Chinese extreme is here, so I'm just tweaking it in between. Do you think that's possible?
I think that's possible. Actually, the reason why I really want to compare against the UK model, because a larger group of Europe researchers did done research several years ago with different regions from Spain to UK, or even probably to maybe North Europe. So they have different ASB models. So those models really you can compare against each other to try to find a suitable model for each different weather climate zones. And so you can use that climate zone hopefully and to represent the local options comfort pressures.
Just to follow up to that, how standardized is your weather measurement? Because of course if you want to do that in different cities, assuming that you don't want to travel all cities in the world, in a way this measurement equipment has to be completely identical everywhere, so that we can start having a database.
Yes.
Are we there?
We can.
No, but first of you would need, certainly, because certainly you wouldn't be able to do all these measurements individually in each city. What you would need, what certainly you need, and you would sit in a minute for Doha, that certainly you have to be able to take the available weather data to be from the airport and then transfer it by a rating of wind, shadow, microclimate into the dense downtown, evaluating these downtown areas, but depending on the more general weather data.
Yeah, you need a mesoscale model that allows you to go from the airport in there. That just gives you the data, but you then need an occupant perception model that you somewhat tweak to your particular case.
Yeah, and I think there I would, in a certain perceived temperature, we are using it in different climates.
And you think it's generalizable?
Yes. That was at least what certainly our, and we even compared it to Mr. Ngo in Hong Kong, who did this kind of as well, how you call it, people voted acceptance for outdoor, and it fits quite well.
I think that's profound, but I don't believe it, because I think you said yourself when we talk about master city, that people's perception of what's comfortable changes even within a generation over time. When we're in Malaysia, everybody uses air conditioning because they use air conditioning. The Germans drive an air-conditioned car, so what was fine for our parents isn't fine for us. So that's a contradiction, isn't it? That we just feel once we are used to a certain, we got acclimatized to an air-conditioned environment, then we don't feel comfortable, we don't get it anymore.
Yeah, no, I agree that the question is, the ASV is more, I would see, an individual local rating of a comfort. I would see perceived temperature more as a general rated, comparable outdoor comfort. So the question then is, for example, if perceived temperature we would calculate for one of the cities, which is then 31, would feel acceptable in that climate, while in other regions of this planet someone would complain because he would feel it too warm. Which is similar to predicted mean vote, where in a certain way Fangler is independent from climate, but reality shows that it's just the other way around, that people in Asia are not accepting higher indoor temperature and humidities, while in Europe, where we're getting it 2 weeks a year, we don't care. So it's as well, I think, depending, you know, a bit on your experience, on your personal experience and your personal expectations. And in this case, you're absolutely right. Expectations are even changing in generations.
I think we'll be looking forward to your presentation materials, though. I think there's not many literature comparing the ASV, the survey-based thermal comfort, versus PMV that's based on human energy balance. And I think there are a couple of papers that comparing the equivalent temperature versus the energy budget method. But I haven't seen a study that paired with ASV study. But one of the consensus is there is a big convergence in thermal neutral. So whenever that's calculated, the heat balance rigid, I think that most people respond. That's the problem comes when it as opposed to hot and cold end, and actually the tolerance of people towards thermal stress is different, and that actually happens both, I think, in terms of the adaptation and in terms of the generation change that happens there.
Yeah, I would say in this respect, Mrs. Yee's measurements are really great, because I would, in a certain way, it would be wonderful in a certain way to take our model and recalculate what the perceived temperature would be and compare it in respect of acceptance to the survey they made. I think in this case that would be the analytic method to take the measured weather data, run the perceived temperature model, and come up with our rating, and then compare this rating to what we found. Okay, so in a certain way, I think I'm more focusing on the method. This is a project downtown Qatar, Doha. This is the center of Doha. At the top, you see where the new museums by Nobel and EMP are. This is the center of. This is where there never had been souks. They now decided to build souks, to build the so-called heart of Doha. And so this is the model. So this is the site going back. This is what they're building there. It's roughly around 1 million square meters of development. They're building on this. And what we're looking on mainly is this. This is, if I go back one picture, this is this outdoor area. This this outdoor space is called the heart of Doha. It's like, to give you a number, this is like 200-meter long and roughly a 40-meter wide outdoor space. And they were totally aware, and in the certain what they already followed, Arup did the master plan, very narrow streets to get self-shading. Now this is an open space, how you're treating this outdoor space. Michel Mossessian is won the competition, the urban design competition. He designed these arcade buildings, but still this open space is quite exposed to the climate. So the question was, now if we roughly go to Doha climate, sun in summertime quite high, in winter 45 degrees, so, and it goes even runs nearly east to west, the big plaza, so you get a quite good exposure. Weather data, mean annual temperature 27, so it gets quite warm, and there's a lot of sun, 1700, a bit less, or let's say remarkable less than in Abu Dhabi, around 30% less. It's more hazy in Doha. It's the outdoor air temperature reaching up to 45, 47. In a certain way, outdoor dew point. Sometimes at nighttime, they really reach each other. So you reach at nighttime whatever 85 to 90% humidity. And that's as well why you're really up to here, where you see we are in the range of 25, 27 grams per kilogram. This is really humid. When it's really hot, it drops down at 40 degrees, drops down in the range of 30%. So there's still, at this point of the day, there would be a certain evaporative cooling potential. Even in this climate, we have a straight northwest wind with quite high wind speeds. They have, so if you, in a certain way, you show 42% of the time, nearly permanently. This is now from May till October, during the hot period, you have permanently a wind. And then in June, you have something very local. We have the so-called shamal, which is a wind which in a certain way speeds up during daytime until a certain, you see, until whatever. In the late afternoon, it increases. So when the outdoor temperatures are really hot, then the wind speeds up, which is a really problem, because This is not a nice breeze. This is a 47-degree hot. So that's me showing over 3 days for Doha Airport how you can see in the afternoon from this is 6 o'clock in the morning, it's low down, and then it speeds up until around 5 o'clock in the afternoon. You really can read it, the daily peaks in the wind velocity. Now, kind of conclusion on the climate, what we then did, okay, how we rate outdoor comfort. That's now the point. We all know operative temperature definition. We just had it yesterday in the lecture. The roughly calculation of 50% air and 50% mean radiant of the surrounding. Now, but there is not considered in this case solar radiation and the humidity. And therefore, certainly, this is the PMV, the predicted mean load. Indoor and outdoor, you have diffuse radiation, solar radiation, you have, in addition, the wind. So you have much more factors to consider. That's why now, in a certain way, they adjusted the PMV method into a PT method, and PT now, in a certain way, defines different comfortable levels. It says a perceived temperature, which is a comparable temperature to what you are measuring in respect of temperature, humidity, radiation, air velocity, mean radiant temperature. This comparable temperature, if it's between 26 and 32, this is rated as warm. Where in the first moment you would say 32 must be all indoor, wouldn't be acceptable at all. Outdoor, 32 is still as a perceived temperature acceptable. Oh, and then if you go between 32 and 38, it starts to get hot, and then above 38, the range, it really gets hot. It slowly as well gets into dangerous. So in a hot and humid climate, perceived temperature of 32 and lower is rated as excellent outdoor. And this perceived temperature is now related to a reference environment. So it's a standard person in a shaded position at a mean radiant temperature equal to the air temperature, 32, calm wind, 50% humidity. So that's in a certain way the standard. If you say you reach a perceived temperature of 32, this is for someone sitting or standing in the shade, being exposed to a mean radiant of 32 to an air temperature of 32 at a calm wind with 50% humidity. So you can calculate this perceived temperature for any outdoor condition, and you get the perceived in a certain way. And this is the standard person is whatever 1.7. It's a certain person with a certain skin, even a certain absorption, a certain working performance. In this case, it's slowly walking. This is what you typically do outdoor. You slowly walk. And then you see, this is considering 172 watts internal heat production comparing to a sitting person where you typically get 120. So if you use the model to rate outdoor sitting, in a certain way, you can assume that in a certain way your perceived temperature would be less. The standard model is based on a summer clothing value at 0.5, which is like a summer's.
Was part of that assumed that women would not be in a public place in Qatar in the middle of the day?
No. It's independent from gender, where even if you look on Funger's original values, it's depending on gender. Absolutely. So we did a neutral. Yeah. And women in Qatar would be fully black dressed with just the eyes slit open. I'm always wondering why they're dressing black, because solar absorption is unbelievable. So it's clear they would never go into the sun because they would just fall. Okay, so, and this is in a certain way, unfortunately Christoph had to leave. So this is how in a certain way the correlation between the predicted, the perceived temperature and the PMV works. So that's where you see normally there's not a linear, at a certain step, in a certain way there is a jump that even at warm temperature are correlating to a PMV between 1.5 and 2.5. But in a certain way, it's not a linear correlation. There are some, and I typically say this is more a as well taking into account, as I mentioned before, the possibility of people outdoor, because you can have a humidity film on your skin outdoor, and then the wind can create much better cooling. You would never accept indoor to start sweating, because you would already start to complain. But outdoor, you can complain, but to who? So, certainly that's a bit the history. So, Funger defined in 1970 the predicted mean vote, and then there were kind of some adjustments made, and then these guys, Gage and al, they did in a certain way to find a better for hot and humid climates, and finally in a certain way they introduced the perceived temperature as a model for rating outdoor comfort in a certain way as a function of the humidity. Now, the British, they have a method to rate outdoor comfort with the wet bulb globe temperature, which is another measure to compare outdoor comfort, and in a certain way, wet bulb globe temperature of 26 would correlate to a PT of around 32, and you see this is where typically we say this is up to 32, this is the warm area, and then 35 or 32 to 38, this is hot, and then above it will be rated as very hot. Now, in a certain way, this is now base of our modeling, and we have in a certain way a model which calculates out of the weather data the actual hour by hour predicted mean vote. So what you can do, and this is now the psychrometric chart for Doha, you can already in the psychrometric chart do a predicted mean vote kind of range. So comparing on each of these dots on the psychrometric chart is 1 hour in the year, so you can already see how many hours are fitting in a certain area. This is a method, for example, how you rate a certain climate. If you do this for Cairo, it looks different because your dots are different. So you see here, this is typically in Doha, you could get day and night, you get 56%, where the PT, the perceived temperature, is already above 32. So quite, let's say, a quite hot and humid rating. Now, if you take this model and now say, for example, and because I think that's what we were missing until now, you define the target, but where are the strategies to improve the outdoor comfort in a certain way? And that's in a certain way what we, in this case, working for a client, he tells us, you have to improve the outdoor comfort in Doha to make this outdoor space more useful. Now, what strategies you are using? So, for example, if in Doha you are increasing the wind velocity by whatever, exposing the people to a higher wind velocity, and this is now rated, and that's important. It's only rated during the hot months, May till October, from 9 till 1 and from 4 to 10 o'clock, because that's what they expected. Normally nobody in Doha goes outdoor between 1 o'clock and 4 o'clock, because everybody knows, especially in summer, it's unbearable. So in a certain way, limited on the outdoor spaces, but even then, increasing the velocity, you see in a certain way your comfort, and this is now, during this year, how many hours percentage are hot or warm? This is 11%, hot 30%, another 68% is very hot. And what you see, increasing the velocity is even reducing the comfort. Now this is now specific for this climate, because knowing that at that time of the day, normally outdoor temperature between May and October is above 32. It's clear the wind is a heat source. So increasing the wind is not creating comfort, especially if you are not shaded. I think that's as well interesting. This is now exposed to the sun. If you do it for a shaded person, the same one, this is now assuming a certain protection, the wind protection. Now comparing an exposed person to a person in a certain way which is shaded permanently during the day and night, comparing to a person which is shaded during daytime but the measure is open at nighttime, because re-radiation at nighttime of your ground, of your thermal capacity, is quite important. So you can see the improvement of the hours where in a certain way it's only warm, coming here from 15%, moving up to 25%, just instead of having a fixed shading to an operable shading, which at nighttime opens, allows you to re-radiate against the sky, is an improvement. Then adding a low E coating, for example, we had it yesterday in the lecture. A low E coating means the heat of your shading, which normally gets warm, and always when I'm sitting at a street cafe, sitting below a typical Coca-Cola umbrella, which is dark red, you can feel the heat radiate. You're in the shadow, but you can feel that it's 35, 40 degree just heating down to you. And I always said, why nobody advise Coca-Cola to do a low E coating at the inside of their umbrellas? Because it would do a lot. You just compare this number to this guy, an operable one. So you can improve, and then comparing it between a low thermal mass and a high thermal mass in a certain way, what a capacity in a certain way can improve or reduce your effect. So in a certain way, that's in a certain way what we are using then theoretically to go through different options to find out. And then, in a certain way, what is interesting, not only to look at over the year, but this is now over the months. So during, whatever, in a certain way, January till December, yeah, all the 12 months, you can see, okay, when in a certain way this measure would be acceptable. Now having the best one, which is operable low E, in a certain way you can see, okay, still in August, it's unbearable. So one of our conclusions was, whatever you want to do in August, you better keep the people out of this space, because this is not. And they said, oh yes, that's what we expected. So in a certain way, so we could, the model could prove what in a certain way their experience had been. Now, I mentioned on the psychometric chart, you can do evaporative cooling at a certain potential, because at certain times, when it's really 40 degrees outside at the peak of the day, you have only 30% humidity, so you can, by adding some humidity, up to maybe 50% humidity, you can reduce the outdoor temperature. So there's an improvement, and now you see the shading with the low E, operable at nighttime, including evaporative cooling. Now this is now over the whole year, you are already up to around 60% where it's comfortable. Now, this was in a certain way not yet enough. So we said, where we have a source to even to get these people more comfortable. Now, what we all know, walking along a store in summer in a city, when the door opens up, you always get the cold air flushing out and just disappearing. So we said, if we build a bathtub in front of all the stores, where it drops down, where this is kind of a sunken area, all the cold air flowing out of the buildings, if people come in and out, would drop out, being connected in this sunken garden. So in a certain way, that's what we call spill air. So if you add the spill air, you collect the spill air, and in a certain way do a floor, in a certain connect the floor to the ground, where it's still 27, but 27 is still quite nice if you are facing. So it's a floor tempering connecting to the ground, plus the spill air, you can improve the numbers. You can see the violet are nearly disappearing, not totally disappearing, but they had been nearly, even in August, nearly at 100%. Now they're going back. If in a certain way you add the operable one, in a certain way even do a better wind protection. Now the wind protection, this is the WT factor, is the reducing of the wind velocity. You do even a better protection, you can even improve it further. And in a certain way, that's how, if you do it over the day, this is the between, in a certain way, the range between 26 and 32 as a comfort range, unshaded. Then in a certain way, you do the operable shading. Then in a certain way, you add the low E in the spill air and the low E in the spill air with a further protection. In a certain way, you can see how you can shift the hours per year from far outside being too hot to a majority being in the comfort range. range. So what we then looked at for this plaza, we looked on 3 defined spots, and in this case we did, that's the shading studies, calculating, this is now for March, for December, how many hours a day you get exposure, now how many percentage of the sunshine hours you get exposure, you get shade, so 100% blue is in the range of 100% shade, 0 or whatever orange is only 20% shade, and you can see this rating now for, you do it for any hour of the year. This is now for March, where the sun is going up. Now, remembering this is going east-west. And then the same now for June, where it's quite critical, where the sun is really up in a certain way. The overshadowing of your building doesn't help a lot, because in a certain way, the plaza is too wide to get a self-shading of the building. That's a macro CFD model of the whole development. Now, zooming into our plaza, which is close to here, in a certain way, you can calculate for the 3 spots we were choosing the wind reduction or wind increasing factor. Luckily now, this is for the main, calculated for the main wind direction, allowing then to rate that at a certain spot, this is increasing the wind velocity, while at other spots you are much better protected. So that would be a space where you put an outdoor space, an outdoor kind of comfortable space. So comparing now the strategies, having a big shading over the whole space can create a certain strategy. Putting people below the arcades where they are more exposed to the spill air, where you can see we nearly push the violet is gone, there's only even half of the time it's comfortable, or having this sunken garden strategy in front of the arcades. So that's in a sort of looking to the plaza in a section. This is the area where you're sitting outdoor in a sort of way, tempering the floor connected to the ground. This is the sunken garden where the cold air spills out from in a certain way the arcades into a so-called, we call it bathtub. Or number 2, being just below the shade, in a certain way you can see the great, in a certain way, differences between the outdoor comfort in the different areas, depending on the measures you decide to go for. And we are in a certain way, we proved it then by an airflow analysis to show that this spill air coming out here, in a certain way, you see the temperature, in a certain way, if the door opens from this shop, there is 22 degree or 24 degree air spilling out, typically heavier, because we know cold air is heavier than warm air, so it stays at floor level, but it spills out. So in a certain way, this is now this bathtub we created in front of the arcades. So in a certain way, you can capture this amount of air, creating, in a certain way, instead of just losing it to the outside, you're trying to keep it in a certain area, which now comparing to the outside, you see this is now temperature comparing. In the bathtub, you are more in the range of 29, 28, 30, where on the big plaza, you are already in the range of 36 to 37. If you do a section on the other side where you only have the arcades, no device, no sunken garden to capture the cold air is pretty fast disappearing, and then in the center of the plaza, that's a section in this direction, in the center of the plaza, in a certain way, this air is nearly already gone. At a certain height, you're still in the range of 39 to 40 degrees. Yeah, that's then a plot where it even reaches above the 40 in the central area. So this, in a certain way, that's the surface temperature. So in your bathtub, you have a floor temperature in the range of 27, 26, because this is mainly determined by this cold air, where in the area where we activated the floor connected to the ground, we at least could keep it in the range of 34, while in the middle of the plaza, even below the shade, you couldn't limit it to a certain temperature. So,
Matthias, what height did you cut the floors? It's near the ground, or is like?
Yeah, no. This is the surface temperature, and this is at a level. I think this is like 80. Typically, you raise.
Surface temperature.
Yeah, one was surface. The other one, the air temperature, are like 80 centimeter above ground. Now, what was very interesting, the architects and especially the client were quite alarmed to say, now if you pull a big shading over this plaza, this will totally destroy the outdoor feeling because you will feel like indoor. Yeah? So one of the proposals we finally made was to create a shading which is for low angles transparent, but for high angles kind of cutting off. So it's kind of this undulating, and it's even retractable, so it had to be retractable. But it allows in a certain way really that if you stand on the plaza and you look through, you can really in a certain way see the top, even the top of this hotel. While if you stand there, and then we did in a certain way the evaluation of it, we evaluated in this case 2. You see the low morning sun, this is now around 8 o'clock, is partially going through, but as soon as you get around noon, depending on what design you're choosing, you get it quite tight in respect of shading, while then in the later afternoon, again, you get still a higher transparency. And then this is kind of calculating the lux levels below it, so you can see you still have spots in the range of 50,000, but over the whole area, this is a much better. Comparing this, I'm now comparing the 2 designs. And in a certain way, this is now comparing the two designs in respect of percentage of transmission. So this is now for the 1st of December compared to the June, where with the improved design we could mainly cut it down in the critical hours in the range of 5 to 15%. So in addition, then we said, now where's the energy coming from in a certain way to do, for example, to keep one of the floors kind of connected to the ground? We kind of estimated, even if you would do, let's say, depending on the quality of your photovoltaic system, 15 to 5%, you can run a chiller and in a certain way provide a certain amount of energy now for conditioning, and we were just defining this. Having a PV integrated on the photovoltaic integrated on the shading, you would create cooling potential even for the connected building out of the shade. You can as well use some of this cooling potential for doing further improvement, because that was a big discussion. Where would the energy come from if you want to do a clear mechanical improvement of outdoor? Because if you want to get it much better, even better, then you do it by passive measures. You may think on active measures. So like, let's say, a photovoltaic umbrella, which has not doing only the shade, but use the shade to span photovoltaic, to run a little chiller which creates cold air at the foot of the umbrella, can even improve the comfort further with still being energy neutral to the surrounding. And I'm closing it off with this one, and we used this, and this was even the base, and you see this is the final presentation for the Qatar soccer. This was kind of for the decision to the FIFA. So you have seen this before, that's the kind of the comfort range. And then what we did, we compared, because everybody was saying doing the soccer in Qatar in respect of outdoor comfort is unbearable. We said, but if you compare Qatar, for example, to Florida, and there was the FIFA World Cup in 1994, and you use the perceived temperature method, you see now that's all the measures. So this is pitching, which depending on when, at the time of the year, it changes a lot. But then, for example, Orlando was quite hot. Now this is Qatar if you do nothing. Then, in a certain way, the typical perceived temperature would be mostly in the range of very hot. But we said, if you do certain measures, what we want to get this guy down here, and this is Mexico City. At that time of the year, when the FIFA World Championship was there, it was kind of acceptable. Now, we want to get this here. And we could show the FIFA that with certain measures in the stadium, low-E coated shading, displacement air ventilation, cooled soccer field. We can do it for the stadium, but we can as well, and these are now the temperature without anything. And improving the comfort with certain measures. You can see you can drop it from 38 for the players to 35. 3 degree in perceived temperature is a lot. And even for the spectators, as long as they're not exposed to the sun, you can as well remove it dramatically. So in a certain way, outdoor comfort improvements typically leads to a win. Thanks. So I would propose, because we are, and I was fast, now we are in the now we have 2 hours, 3 lectures, 2 hours, a bit above 30 minutes. I would do just a 10-minute break. We have another good hour to go, so we have after a 10-minute break, grabbing some coffee or whatever, okay, and then come back, and then we would go on with Peter's lecture,
Very quick.
okay, and then make sure we have enough time for the final discussion.
I used to work in a computer with all stores. Computer. Where it can work with previous paving of some sort, where you can add pressure to it and actually extend it out over an area. And if you do that, you can redirect it depending on the model, as to where the shaping is of the floor, you can redirect it on targets that would use it to assist in those areas. You may have to add to it, you may have to chill to it, or take the rest of the air.
Overall, we should take this as some possibility of the market, then we should reduce the payment pressure. So because the price per square meter is higher, so what we can do, this is raising. What we can do is just make the indoor area smaller. That you can keep the total price at a stable level. If you go with your area, go with your price per unit, your total price will increase faster. And then you cannot afford that.
Yeah, no, and I think in a sustainable approach where we want to build less, in a certain way, your reduction of the specific unit in general, in all the numbers you're showing, which are so breathtaking, how much square meters you are going to build or how much housing units you need, is clear. If each of the housing has 20% less, at the end you will build 20% less, which for the environment is a relief. So not only that you do it in respect of the economy to say, okay, people have a certain amount, either they decide not to buy an apartment. If I want them to buy an apartment because that's my core business, if I do smaller apartments which have the same quality or even maybe a better quality than a larger one, but they invest less money, I get more people into the business to buy an apartment. Yeah. So I think that's quite interesting that in this case, your interest as a developer and the interest, I would say, of the environment to build less is similar. Even when I heard the numbers, how fast you're growing, how many cities, you can see how many cities you are intending to build in the next 20 years. I'm asking myself, where is the building material coming from? Where is the energy coming from? Isn't there a limit? And then you showed as well the tendency that the energy consumption of urbanization is nearly 4 times more what the people, or twice what the people spent before. But where is this additional energy coming from? Is it coming from mobility? Because people lived in a house in the rural areas before. They needed heating, they needed light, they needed TV before. Now they're moving to a city. Where is the doubling of the energy consumption coming from?
They move inside, they need to consume energy. Right? They also need to consume energy, so the people, more and more people come in, they should consume more and more energy. But with this energy saving technology, we can reduce this amount.
Is more like if you are using energy now and you just go to a different location, you still use energy, right? But actually, one question is more like, in response to Chongqing's claim, in China, normally in the rural area, there are people there, they don't really spend much energy. And their life quality is quite different from the normal people in thinking. And so if they move to urbanization, their life quality can be greatly improved, but also with more energy required.
Now, does your energy number you're listing, is it including the mobility? Because I'm typically wondering that normally in a rural area you lose less energy for mobility than you use in an urban, because you have in an urban environment you have to travel from your home to work and
Doesn't
back.
include mobility.
It's not included. It's only specific on it.
Yes.
So
But more and more people move in the city for the.
So this means that urbanization for you means as well increasing life standards. Because the rural area, you said, they are living even below a typical standard. And if they now move to a city, so it's quite interesting because normally you would say urbanization means people are just moving from the rural area into the city, which normally we would say the energy consumption should be similar. But if you say this in the same time means that they are in a certain way increasing their life standards by a factor 2, it means they are doubling their energy consumption.
Isn't there also development happening in villages that are becoming urbanized in China, like around Chongqing, for instance?
Yeah.
Where so that people are actually staying in their location, but the location itself is changing. But the villages are becoming, they're demolished, but geographically, industry is coming there, and the villages are developing into enormous urban agglomerations.
But then people's expectation, then in a certain way, moving from their old house to the new house, their expectations for life standards
Hi.
is.
But the other thing is more like when you just live in a single house, for example, I can still call it house. The use of air conditioning, just for example, may not be as high as when you live in a urban city area. It can be you really need air conditioning sometimes. But if you're in a not very populated area, you may not really need air conditioning.
Or you may never have heard of air conditioning.
Okay, but then it means that in a certain way, your dense urban development, and that's what Chongqing showed, is in a certain way not using the natural potentials the standalone single house, okay, had the opportunity to use because it was better exposed to the wind. It had windows on both sides of the building. It had the possibility to cross-ventilate it.
Exactly.
And now you're in an apartment blocked, in a sort of more or less blocked, and your ability to use natural resources is limited. That's why you have to use. I want to answer on Carlos' question in respect. I think, Carlos, you made a quite good point in that respect. We were talking about perceived temperature or ASV, which in a certain way is, you're absolutely right, more or less focusing on the thermal comfort. And maybe we should talk about, in a certain way, improving outdoor quality. Outdoor quality, in this case, would include air quality, ozone level, acoustical quality, acoustical comfort, and because what does it help if we put a playground in the shade, if it's close to a highway where it's very noisy and you get high ozone levels, where the kids are dead after playing 5 years there, but they are in the shade. So in a certain way, I think holistically, you're absolutely right. It's a too limited view to say improving outdoor comfort. What we need to do is improving outdoor quality. And then outdoor thermal comfort, acoustical comfort, and air quality are the the different aspects.
I think actually in addition, it's more like what about service? When you look at the occupancy, they prefer how they prefer outdoor the place they want to play. Not only thermal comfort, but also I call it more like environment quality, which really covers like acoustic. If it's too noisy, definitely don't want to stay in the area. And the other things regarding if you are close to a road which a lot of pollution from the cars, from the traffic, they wouldn't stay in that area as well. So all of those factors should be considered.
Yeah, but what I was meaning is like when you do a study like that, on one side you're scientifically taking into account a series of factors, but then when you're surveying the people and trying to contrast those factors with a real perception, you should be able to also measure that factor. Because you were showing so people stay more time or less time in the playground, but I didn't know if there was perhaps a road in that side of the site, just beside the closest building. There was this big road because all the cars of this huge development have to go to that road, and that's why people don't stay in that square that much as opposed to the playground. So we just, yeah, so it's more like a...
Yeah, and it's something you're absolutely right. It demands that you as well measure the side of the thermal comfort. You measure all the qualities and the noise level. And for example, for Masdar City, we did it. For 1 year during the planning phase, master plan planning phase, we documented exactly noise level, air quality, the side of all the other climatic data to to be able to describe the quality you could achieve at that point. And I think another point you make, which is really in New York, is a perfect place for this. That, for example, indoor comfort is so strongly determined by outdoor comfort, because in spring, normally in winter, you can easily open your window. Even I live downtown in Manhattan, it's fine. And then spring comes and the first sun comes and everybody starts his window units. Suddenly your urban surrounding is kind of acoustically and thermally polluted because everybody dumps his noise of its chiller and the warm side of its chiller into the neighborhood. So your ability to do natural ventilation is just killed, because if you open your window, you get the warm air and the noise of your neighbor's air conditioning in your apartment. So which in a certain way is like, my God, this can't be a solution. So if in this case, you would have a central system, for example, using a geothermal chiller, which would be without noise and rejecting the heat instead into the urban environment, into the ground, you still would be able to open a window. So I think that's another side effect, because at the moment looking on your graphs, it looks like, oh, let people stay with a single window unit because they use less electricity, because maybe it's so... Okay, first they pay for it, and I think that's one point I noted in my notes on your lecture. Individual billing is a key point for sustainable behavior of occupants. Because if you don't pay what you spend, there is no connection. And I think if you do it, if you in a certain way exchanging people's individual window unit where they pay the electricity by apartment to a central supplied conditioning, and you don't meter it, then it's clear that your energy consumption is quadruple, which your numbers showed, because I would say, even if people, and I think this is even true in Germany. If you don't bill people what they spend, they use the window to control the room temperature instead of controlling the thermostat.
They use as a free stuff.
Yeah, so that's not this is not an issue of just saying, oh, that's the Chinese society who's behaving so badly. I would say our society is the same. I would say this is human behavior, as long as you are, even if you understand it, as long as you don't feel a certain punishment, and money is the best punishment we can use. People they feel like, oh my God, what does it make if I just reduce it now in the overall, because my neighbor who is just spending as much as he can because he doesn't have to pay for it, I do the same. Let's spend as well because the other pay. I don't need to pay for it. I think that's a key point. Definitely a key point. What you should. Yeah, so it's so nowadays. Come on, it's so easy to include a heat meter, so an energy counter, even in slab cooling system or central systems per unit, and you can even buy radio control. You can read them, so you do not even have to go to their apartments. So I think this is a technology for the linked hybrid project in Beijing with MoMA. We proposed it to do this individual accounting because exactly that was our conclusion. That we said, if you at least at the moment they have the ability to build it. It's not built. They didn't build it out of financial reasons. They said we would spend too much money on it. How it works in Germany, you as a tenant, you pay for it. You pay for the service to have this kind of certainly counting, but in a certain way you pay easily, whatever, let's say $50, $100 a year for the service, because on the other side, you don't pay your neighbor's energy bill by having a flat rate. Everybody's paying everybody's spend.
And are you able to control it?
Yes, sure.
Or just on
No, you can individually control it.
But beyond that, you can give some kind of data feedback to allow people to operate their systems more economically, just as comfortably.
Yeah, that's why we just call design by occupant's behavior. If the system only designed by just what you imagine, just your system cannot be controlled by yourself. It's controlled by a central system, and you cannot shut down by yourself. Even for example, you go out for a long holiday, but still need to pay for it because this is get a deal with this property developer.
Yeah, but that's easy. That's in a certain way, if you have your individual, let's say your individual accountants for the energy you're consuming, you can have your individual flat valve, which has a presence or whatever, a control that if you leave, each individual heating control in Germany has a vacation setting. So you push a button and the system drives down and keeps it from freezing, but they know people are gone. And then,
there's some people from Apple developed a thermostat that is beautiful and learns your behavior and sort of teaches behavior. And you can also read it on your iPhone and set it from the movies. When you're coming home, you turn the heat up a little bit.
Now, if they could just learn my wife's behavior.
That's another model they're working on.
Totally different model.
Actually, I think we should go back to the first question.
Actually, the question would be a hard one. I will try to maybe, I think that's also kind of requires some discussions about that. So let's, I think give example like what was the community development. They are actually, I like what Chongqing mentioned, they are one of their target market is the first buy. So when they kind of set up the family and with young kids and small children, so their original community is more like a kind of set up by targeting this type of clients or occupants. But right now, actually, many of Vanke's communities actually has been, I think, some of them are more than 20 years old. So in those kind of communities, actually, the people, age groups have been changed. Like we mentioned, young kids have become, young adults, and the people are getting older. So right now, they're actually experiencing, as they have a very huge plan how to renovate their old communities to justify their age group changes in that. But I think that really requires a lot of, design considerations.
Yeah, no, you need it. And if you look at the American society where the suburbs, you call them empty nesters. And now you have empty nesters. That's a traditional development. And then these empty nesters sell their suburban house and partially moving back into the cities because there is where it's nicer to spend the evening of their life because they want to have culture, but they don't need a playground because they are now grandparents. And I think especially in the Chinese society where it's interesting that where at the moment it looks like the kids are raised the grandparents. Yeah, which that's quite interesting. So the grandparents have an important role.
Sure, for the first buyer, and so we should provide a suitable playground for the elders to come out.
Yeah.
And also, the children only play longer if the elder have a comfortable play room for them to rest and watch. So they are together.
Yes. And then you mentioned one other point where I thought that's interesting, an interesting point. In respect of outdoor quality, you said if outdoor quality is not good enough, not attractive enough, people stay home, and you have this problem of obesity, of the fat kids.
Yeah.
You say obesity.
Because the children play the
Obesity. So in a certain way, and it just reminded me, and I showed my students like 2 weeks ago, Masdar. In Abu Dhabi, in 40 years, they changed their living from living in a tent to living in a high-rise. They instead of riding the camel, they're driving the SUV. Instead of eating very diet dates, they eat everything. The diabetes rate in the United Arab Emirates is the second highest in the world. They have 35% high diabetes, fat people. So in a certain way, and it reminds me, and then maybe in your case, the question is, now, in your rural area, did you have the same problems?
I've been thinking about that.
Because
That can be a trend, right?
Yeah. No, because
it's an urban suburb trend.
Exactly.
But there's another, when you get to the scales that you're talking about, how people move around is a crucial part of things. I mean, there's some discussion about the high cost of building subways in America and how America can't afford it for whatever reason. And so there are some people who are trying to do studies to suggest that actually you cannot afford not to. And one of those studies is the high cost of sitting in your car eating a McDonald's and then needing to be treated by the healthcare system because of all the diseases you got because you haven't walked in 5 years. And if you go to any city, that Paris or London or New York or Tokyo or walking cities, you look around and people, it's same culture, same country, they're thin as compared to the people in the places where they sit in their cars all day long. So my friends and my wife know I'm a little bit annoying on the subject of transportation, but it seems to me you are not critical of the fact that beneath these towers is a massive amount of parking and these people get in their cars and they use them all day long. I wonder when you build at the scale you're building at, whether you mightn't think bigger. Maybe you build a project that's not 2,000 families, but 10,000 families, and at that scale you try and influence local city policy with respect to transportation.
Normally, like that city, Bangkok city I mentioned, is really far from the city center because there's more than 14,000 people who live inside. Normally we will ask the government to establish, for example, public bus, and even when we choose this land, we choose close to a subways plan. In the future, they should have some subways for that. So sometimes because we are the leading developers, so we sometimes build a land far away from the city center, and then we will influence the government to make the improvements around us. But then will be more and more people come here, and we build a tower, and then will more and more people come in to live. The government should make this road, make the bus, make the railway to us, to this big community here.
But maybe you should also build downtown.
Expensive.
Well, but maybe it's expensive, but maybe you can make, I mean,
I know, but for
because when you build
half the size, double the price.
When you do that, when you build outside, you're actually perpetuating the suburban model, right? You set up this disconnect from, from culture, from shopping. Well, at this scale, these are
So, but that would be following this question from Peter now. And you said, okay, you're trying in a certain way to have an influence on politics that lead to transportation to your sites. Now, for your developments, you're normally building per apartment a parking spots, or what is the density of parking spots to apartments in your developments?
For parking area is around 1 point per family, two cars per family.
2 cars per
Two cars.
So maybe.
Soon to be 3.
No.
1 point car per family.
One car.
What about density of open space? Do you have an open space requirement? If you're working on 208 square feet per person in a unit, what's the square footage per person outside?
Outside.
But that's a good point, because in respect about, we now talk about outdoor comfort. In a certain way, if there is no outdoor, you don't have to talk about outdoor comfort. Now, yeah.
We don't have these numbers on the side for the data. We have is the Greenland ratio.
Yeah, but if you take like the development you showed where you did the measurement. Now, if I remember your kind of site, it looked like at least 50% of the site were still outdoor, and only around 50% were covered by building. What is your typical? What would be your typical number in respect of open ground to kind of covered ground? Covered ground means building.
Yeah.
I think there's a general ratio called green area ratio that's approximately by building
40% has to be outdoor.
be defined as covered by vegetation. And
So is it
sometimes-
possible that in the usable spaces that it might actually become too high a density for comfortable use at certain times of the year or certain times of the day? Because that 40% isn't all usable outdoor space, I would assume. Some of it's topography, some of it's security buffers, some of it's parking, some, other things. Is it possible that your outdoor space is actually becoming too dense at times, where people say, it's like the pool. If the pool's too crowded, I'm not going to the pool.
Yeah, no, in some way that's nice. In some way, and the consequence is clear. If we are improving the outdoor quality, there is more pressure on the outdoor quality, and then maybe this, in a final consequence, you're right. If everybody would go out and everybody would go to the playground, it would be totally crowded. People would complain that it's nice to go there, but it would be nice if it wouldn't be so crowded. And in a certain consequence, this would mean you have to increase the 40% to maybe 50% or 60%, because if you push the people out of their apartment because you want to set down the temperature, and in a certain way want to have them spend more time outside, it may lead to a higher demand, which in a final consequence may lead to a demand for changing code, that you need more outdoor space.
And by many experience, we check many buildings around Ranking Group, and we can get just regular number for the per square meter for playgrounds outside is 0.25 per family. 0.25 per family per square meter. 0.25 square meter per family.
So a quarter of your apartment is outdoor playground.
Yeah.
No, wait, say that again.
0.25 square meter per family.
Per family.
Per unit.
No, per family, but per square meter of family, or per family in total?
No, per unit. Per unit.
Yeah.
Per individual unit.
It's a quarter of a meter times
So
the
it's-
number of families.
Oh,
With more than
So it's
400.
500 square meters for 2,000 families.
Yeah.
that can. That's.
Well, but so,
But
and
that's
so
very
I would say,
Well, you
I'd
cannot
make
all
another
people
observation.
at the same time, except the earthquake, right? Some people still live inside. So now we're going to increase this ratio.
But
This
you
by
said,
experience.
if we understood the number right, you said 0.25 square meter per unit built.
Yeah.
So assuming we have 2,000 units, as Peter said,
Yeah, the
2,000 units would have 500 square meters playground. Only.
But
That's
There are
unbelievable.
some other areas.
this unit,
Not
but
just
this
for
area is
the-
for the children playground. Children playground, but you should depend on your equipment around your property. If outside there's a very like high park or big park, so you can reduce or something, just adjust this ratio. But this ratio is just by experience, only for the children playground.
Is there any use of rooftops for exercise courts, for running, for
Normally,
gardening?
the high tower is more than 30 stories, so the rooftop just a small area. Normally, we will just regard as like equipment rooms.
Right.
Just an observation. On your site, the playground sounds a little small. I mean, it's twice the size of this room. So this is 25 square meters, this room. I'm just guessing. So if one thought that there wasn't quite enough land per person in a project like this, again, I don't think you can solve that yourselves unless you want to buy more land and spend more money and I guess make less money. But that's where the issue of roads and transportation in the city. The city gives away vast amounts of area for parking and for roads, and that can be recuperated if a more intelligent transportation system is adopted.
Do you pay for the ground? You pay a loan, or how you do it? Because certainly in China, ground is not owned privately. It's only government.
Is that correct? You don't buy the land?
They don't buy. They only rent it for 70 years.
So rent more.
Yeah, no, that would be my point. If you don't buy it, now, in a certain way, if you get a certain amount of land by the government, are you obliged to build a certain density on it? Does a certain piece of land comes with a certain density? It's a zoning. So you have zoning laws that comes with. But if you stay below the zoning, it's your.
It's allowable, but less profitable. So
Yeah, no, it's less profitable. But it is something less profitable means on the other side now, following Chongqing's approach, more function, less space, less payment, saying if you build instead of 100% allowed by the zoning code, you build only 80% because you build the apartments smaller, but nicer, better to use, cheaper to run, and you have better and more outdoor space. The whole development may increase in the quality, and then definitely in respect of happiness.
Yeah, it is especially for the high buyer, the first buyer in this big city.
Yeah, and I think it's much cheaper to build 20% more outdoor valuable playground than 20% more program.
So the little building that we showed has rooms that are smaller than normal, much smaller than the normal, than a Holiday Inn, let's say. But no one has ever said they're too small.
Depending on the family structure.
Well, it may depend, but this is a client group that's actually has had bigger rooms in this same project. And these smaller rooms, I mean, I'm trying to make the same argument that Matthias is, that you put more money into the land, you build the same number of units, you sell them for the same price, but you make the space so efficient that people think they've got more space than they're paying for.
And it correlates with the size of the largest TV screen. That is, the rooms can get smaller as long as the TV screen, the virtual world on the outside, gets larger to fill a wall. So you can have virtual environments.
Or you
without
just
going outside.
You spend, I mean, the other thing you spend a bit more money on is windows, you know. So this Kripalu place, there are 500 rooms, this is only 80 of them. they're the first ones filled, and now this you can't do, but they increased the rates by 30%, and they're still filled. So it's the principle of maybe adding to in your list of qualities, quality or perceived value. It's not just how many square feet, and it's not just how much you spend for energy, but it's perceived value. And
which fits in your yeah. But this fits in your strategy where you said less space. If the perceived space is the same or even higher than what you built, you will build more, but the quality will be less. And now you build a higher quality but less space. But in some way, this might be as well interesting for you, because then the apartments in a certain way are better affordable because they may be cheaper, but the perceived square footage would be the same than if they would be bigger but even more expensive.
There is a confounder, though, and it has to do with whether or not pets are allowed. I noticed in one of the slides there was a picture of somebody holding a cat. Yes. In the apartment. Are pets allowed? How are they accommodated for? And is it something that is like in the U.S. a growing trend where more people have to have pets? Therefore, you have to have more outside area for pets.
Yeah.
You have to have more accommodation in
gardens.
Is that allowed?
Yeah, it's allowed.
Is it in demand? Are people actually asking more for pet accommodation?
Sometimes they will ask for the pet accommodation, but just we will separate a small area just for the pet coming inside, pets, and just pet around.
So it's something you have to accommodate over time? Or do you see it as a growing part of the list of demands?
But not that specific place. Maybe just in some community, just let it be.
No dogs, just cats?
With dogs, yes.
No. Little dogs. Right.
Yeah, okay. Guys, I think we should look at the time. I think it was a great session. Yeah. Right? Good discussion. Thank everybody for staying, joining us. Thanks for the moderation. Thanks to the lecturers. So, we do it again. Thanks.